Hello. Today, what I'm going to explain is my current state of my asynchronous based um, table model component, which is using Qt's multi-threading um, feature set to make a table model that is asynchronous, but for the most part will try to act like QSQL table model. And the big advantage that I am working towards as a feature of this component is, of course, that the having the database um, communication be done on its own thread will make the user interface more responsive and not freeze during times of SQL queries that have very large returned data sets or when there is a slow connection. Um, QSQL table model is great, but it is, of course, as I researched, a synchronous implementation and can lead to some freezing of the UI. So I thought, why not have some fun and as a great project to dive into multi-threading and its advantages, try to make a QSQL table model like component that is asynchronous. In getting into implementing this functionality, I started thinking through where I could have my varying components. And right off the bat, one thing which would have been nice, but was not available, would be to have the QSQL database class, which is the database connection object, be on the database thread. Um, and the QSQL table model on the main UI thread, but that won't work. I believe there's a runtime error or something along those lines that occurs. Um, so, um, I guess I'll just write it out here. dbcon QSQL table model, um, trying to initialize a QSQL table model with a DB connection object from another thread cannot happen. The next thought that I had was, well, what if we had the view, the Q table view on the main thread and the Q SQL table model on the DB thread. It would successfully be able to connect with the DB connection object because they're on the same thread or have the same thread affinity. But again, I researched it, and research said that this wasn't possible. So, um, what is one to do if you can't just use the components out of the box like you want? You start making your own components. So I made a what I'll call table model that is able to talk to a QTable view on the same main UI thread and um, is going to have code that allows for itself to be able to talk with a DB connection object on an auxiliary or database thread and bring about the asynchronous table model that I wanted to have, and of course bring about the big benefit, which is a UI that is less likely to freeze, given uh, very slow connections or very large database returned data sets. So, um, what I noticed off the bat was that I wanted to have a way for table model to um, have some base functions work just like they do with QSQL table model. So table model has a set table function. Let's say we can set it to tasks, and has a select function. Now, set table makes a query that returns the field names of the specified table, and select takes field names and retrieves um, record data uh, from table. So this is a big desired trait of components. We want to be able to configure our components. We don't want to hard code the components. Um, Thus, the components won't be able to be used out of the box with hard coding if there is hard coding. If there is not, and the components are highly configurable, one can use a component out of the box in a new application and get the component up and running and enhancing and achieving um, the new application's desired feature set. So, in our case here, these components, or this component, has the ability to configure the table that is queried for. We can also set a new table in the middle of the application running and select again and have the table model data, which is in the memory of the application, update itself off of the query of data off of the newly set table, which is a great um, dynamic feature as well. So, I explained the functionality I wanted to replicate, um, just these two functions. And why don't I actually show? I'll actually go ahead and show what happens. So I'm going to run the application, Here's my table view, which is hooked up to my table model and has some not so well formatted data. And these are supposed to be work log tasks. And like here's the task description. Here is the task time duration. Okay. Now let's get into um, achieving the implementation of cross-thread messaging to um, bring about the set table and select functionality. So again, we got our main thread and db. Um, each thread has its event loop, right? The way that Qt allows for cross-thread messaging is via a queued connection. So in the case of my table model, it's going to have, let's say, a signal like send select um, and this is I'll write it out like I just said, a signal and the database will have some kind of DB connection object or DB class interfacing with the DB connection object, and it's going to have a slot that will be receive select, and it will have a signal that will be um, send select end, and this guy will have a slot that will be receive select end. So um, the select function could get this whole operation series, as I like to call it, rolling. So select would call send select, which would call receive select, and we would also, of course, pass in the query, and this would trigger receive select to um, fire off, and execute the query, and send select would then return back the query data. And um, the slot, which is connected to send select, would be able to operate on the query data. Now, I did not end up using the signals and slots. Why? Because it is an observer mechanism, and um, if there were multiple um, table models, then um, send select end would fire off for one of the table models, right? Let's say it's like this. So send select end would receive a request, and be what's used to reply the response data, and it it's going to notify via signal slots observer mechanism every um, connected observer, and we only actually want it to be this guy that receives the data. So um, this observer based structure that I wrote here, which is great for things like model view controller framework, was not the way to go for my setup. What I ended up doing was this. dbcon sorry, just give me 1 second. So select would fire, and what it's going to do is q meta object, invoke method, and let me just look at my code here. Okay, don't look at some of this because I need to explain why I structured it the way I did. Okay. dbcon pointer call it receive select. So dbcon pointer is going to be the db connection object instance on the db thread, and receive select, even though it's a string here, is the name of the function to call on the db connection object. And we are going to pass to it this, which is the address of the specific table model that we want to have the return data sent to. We are also going to give it the function within that class to call with the return data passed into. And lastly, we're going to give it the QSQL query return data. Okay. Okay, cool. So dbcon thread is going to have a receive select, and of course what I want to do is, oh shucks, let's say query string right here, or better yet, to make it understandable, oh, or you know what, oh no, darn thing. Oh god, my gamer pad and the hotkeys I have on it are sometimes troublesome to remember. Oh no. Okay, and we're also going to pass the query string. And here is receive select, which takes as parameters QString query string, which I'll call that, and it's going to take table model pointer, we'll call it mod. It will also take everything else here. QString callback, and actually, yeah, we don't need this right here. this is the return data, and um, we're not giving the message to the DB connection object the return data. The return data is what will be returning the return data, or the DB object will be returning the returned QSQL query data. Okay. And Qt makes it really easy. All one has to do is say QSQL query, and have it constructed off of a string that is the query string. And then voila, query will contain the QSQL query return data. This is the function that is synchronous, um, and encapsulates and abstracts away all of the SQL database communication, fetching, requesting of data, and receiving of data for the database, which is most likely in Arizona or some other server like land. Q beta object. And we're going to do the same thing and do our callback, which is new to me, and I always hear about callbacks. And look at me now. I'm doing callbacks in my code. It feels great. Okay, so we're going to do invoke method, and we're going to invoke it on mod. And we're going to call it on the callback. And we are going to pass in the query data. So this will call reply select. Sorry, my chair is squeaking, and you guys are probably hearing that. And reply select, of course, is going to take the return data and have the model set its own data off of the QSQL query data. This is a generalization, but in pseudocode, but hopefully you get the point. So we have the life cycle happening where we're using a we're using messaging. We're not using observer mechanism messaging because this structure makes much more sense having table model request data from the DB connection on the opposite thread, and we're giving the DB connection thread the instance of the table model to pass back the return data to, and the name of the function to call uh, for that table model instance to be able to know what to call and pass in the Q SQL query data with. Of course, I analyzed this structure, and one thing. Okay, I'm going to get into this implementation and analysis, but I want to explain one other aspect. So, the event loop, yes. The way that cross-thread messaging works, which is like um, uh, which is like signals and slots here, where the object that has the signal um, calls another object on a different thread, and it's also like my other example down here. So invoke is being called from table model, which is on the main thread, and it's sending a message, which is the calling of receive select, and it wants receive select to be done off of the DB connection pointer, which is on the other thread here. The way that this cross-thread messaging works is you send the message for the function to call, and it is put into a queue. And the event loop takes whatever's first in the queue, processes it, and in my case, the function that's called and processed via the queuing has instructions for calling back and sending a message to the main event loop. And I won't write it in, but there's also the queuing that happens again. So this is something to take into very serious consideration, because it's an integral aspect of how um, how the engineering and data structures and processing actually works with multi-threading and Qt. Okay, so the problem that I was seeing was this. Table model, given the course of its life cycle, which could be many years, might get many functions which are operation series that are multi-threaded. Like there could be an alter one, there could be foo, and many, many more. Um, this would mean that anytime there's a desire for anytime there's a desire for another function to be created on this side, we would need to have pairing, which is this little chain here between the parallel function. And it'll be fun. I can use a cool aspect of Photoshop here. So we're always going to have to add new ones each time we want to add another function to table model. Another aspect is the DB connection object here is going to have to know of, needs to know of table model. Needs to know of table model class. Well, what I did was come up with a structure that solves both of these problems, which are maintenance, maintainability, and scalability, and modularity problems. The DB connection type object I would have here isn't that modular because it is hard coded, if you will, to know of and only work with table model classing. Right? So, see here, table model, like a part of its receive, select, and every other function that is the parallel with table model needs to know about table model class. So that decreases the modularity of the DB connection or DB interfacing with connection object. So for these two issues, here is what I did. I'm running out of room here. Okay. Give me 1 second. Okay, and I am back. I took about 5 minutes just to regroup. So I wanted to make what I ended up calling a DB Talker friend class. And DB Talker friend. And table model would both be on the main thread. And what I ended up calling DB Talker, which was my interface class to the DB connection object on the DB thread. Now, the general idea was that DB Talker would be the intermediary object that would be a way for any application specific class to make cross-thread database requests through. So let's call this app class X, and let's call this next one acme widget. And um, the communication with the database would be done across the thread via a um, a simpler, less complex, less maintenance heavy set of calls. The way that I want to just change one thing. Each application specific class object would get their own database talker friend, and this is what makes it so that the responses from DB Talker to each DB Talker friend can happily be then relayed back to correctly back to the application specific class that originally requested the database data. And what this does is makes it so that the DB Talker code and the DB Talker friend code won't need to be altered when there are extra um, um, functions added to whatever the application specific desiring to be talking to database class uh, wants to add in the future. So, I can imagine you're having some questions. So let me actually go to the code now, and I will explain. So here is DB Talker friend, and here is the function for allowing the application specific classes that want to talk to a database. Um, uh, Here is the function for achieving that. Whatever the application specific class is, it can have a DB Talker friend member like my table model does right here. The reason why I have ID is important. There can be multiple operation series going on at once, where table model might have X, Y, and Z active operation series, which this one might be a set table function operation series, this one might be select, this one might be some future function operation series. So, how do we know that what is returned back in the chain here goes with what operation series? We know by way of giving a unique ID to our operation series when it commences. So, right here for set table, before things get asynchronous, I'm generating a unique ID. I am doing another thing here, which I will explain and is new. Functions is a way to map the ID for the operation series to the function to execute at the end of the loop of the operation series. Set table end is what will be called when there is a full cycle and there is return data brought back to the table model on the main thread. I also have a vector of pair of strings. This is a way to remember what the table name is and actually set the table name upon the function finishing. Because we don't want to set it now because the operation series might not be successful, so we'll set it at the end. And that's what I'm doing right here with set table end. I am actually dealing with the SQL query here. The way that I'm setting the properties at the end of the operation series is with process reply. So process reply is the slot hooked up to the signal of DB talker friend, which is reply receive, and you can see the hookup in the constructor up here. So we're connecting the DB talker friend members reply receive signal, which is the callback done by DB talker over here, and we are connecting the reply receive signal to this, which is the address for the specific table model instance, and the slot, which is process reply. So process reply iterates through the properties that were set at the beginning of the operation series, like the table name, and actually sets the properties because we're at the end of the operation series and most of it was successful, so we can actually set the properties and finish the operation series. The last step, of course, is to get the matching conclusion function of the operation series to be executed, and that is found through the functions map given the ID set at the beginning, right up here. And I first of all don't look at that, I think that might not be necessary. I call the I call the function using this weird syntax here, and that actually um, calls, in our case with my example that I just showed, it calls set table end, passing in results, which is the QSQL query data, and that then executes set table end, and um, has field names be set, and I have my field names called feature field names. It's just a way that I decided to name my field names because select is what actually makes the table change to the new table. So set table sets the table for what the table will be in the future if select is called. Thus, I called my field names member future field names. It's just a way for me to uh, to have a better naming for what's actually going on. Okay, so um, in recap, the reason why this setup that I did is perhaps better is I am getting rid of the problems I explained over here. Which I'll just drag it. Or was it up here? Yeah, I'm getting rid of the problem I was seeing with my original um, naive implementation. So if I want to add cross-thread functions that are new operation series, I don't need to alter the DB interfacing object, um, and I have a DB interfacing object that doesn't need to know of table model or whatever the application specific class is. It only needs to know about DB talker friend. So given this new setup, I have a more I have a more robust, maintainable, scalable solution. I hope. Okay. Um, I might want to explain some other problems I was seeing. Okay. So one thing I was seeing that I wanted to have happen was if there is a set table operation series that hasn't finished yet, and then there was a select that executed, I wanted to have this select be in a holding pattern until the set table finished, and then the select could call. because this is replicating how QSQL table model works and how synchronous code works, which is as a client coder desires. If you do set table and you do select, you want the select to work off of the field names that set table set, not off of field names that set table didn't set and were pre-existing. What I did for this was this solution, which is where is it? Select if set table op series count. So if there is active operation series for set table going on, fire off a queue timer that calls select again in 200 milliseconds. Select again does the same check. And if there still is operation series going on for set table, then do select again. Once there is no set table operation series happening, then do select. This will fire again. We'll actually begin the process of creating our select query off of the newly set field names from set table finishing, and do our request and thus begin our process of our select operation series. I made this a count as opposed to a boolean for knowing that we are in the clear for executing a select, because we could have multiple set table operation series happening at once. And it would lead to a bug if I had a boolean, and here's why. So if I had set table like this, or somewhere previously in the code, set table begins its operation series. This second one begins its operation series. This one goes into a holding pattern. Set table say makes an is setting table boolean true. Then this one sets it to true again. Both are executing. Then the original one returns and sets is setting table to false. We are in a situation where the select could come back and check to see if is setting table is false, which means it is to begin its operation series processes, which is undesired because the client coder expects for the select to select off of the most recent set table function, which is why is setting table is not the way to go, and the way to go is with a count of the set table operation series that are currently active. Alright, I'm noticing my computer is getting a little slow, so I got to delete that layer. I'm trying to think through some other coding problems and solutions I had. Okay. I would have liked to have table model um, be able to inherit off of DB Talker friend, because then I can make reply receive a virtual polymorphic function and override what it does when DB Talker would call reply receive, and would separate the functionality of of it would draw a line in the sand for what DB Talker friend functionality and functions are, and what table model specific functions are, and um, it does what inheritance helps out with, which is organization and thus increased modularity. So I wanted to do it like this: public DB Talker friend, and then public um, Q abstract um, table model. But alas, both of these are Q objects in their base class, and they need to be Q objects. DB Talker needs to be because we're using cross-thread communication in Qt, and we need to have uh, the the objects being messaged upon be Q objects, which allows for usage of the invoke method um, cross-thread messaging. But there's a compiler error when you try to have a connection of signals and slots, which I had via my invoke method function calling. I forget what the compiler error was exactly, but it happens, and one can't do multiple inheritance where the base class is Q objects. So I couldn't do that. Um, I then thought of doing um, the delegate interface, or the delegate pattern. So maybe have table model um, inherit a DB um, talker friend delegate interface, and of course the same here with the Q abstract table model. Um, I don't want to explain delegate pattern fully. This my presentation here. I need to wrap it up. Basically, uh, the delegator class, which is table model, would accept a delegate class, which would be the DB Talker friend delegate, and would have a calling of the wrapper um, delegate function that would call the DB Talker friend delegate within it. This isn't possible because, once again, DB Talker friend delegate interface is planned to be called as or using cross-thread messaging, and thus it would have to be a Q object because that is how one does cross-thread messaging with Qt. So back to square one. It's the double queue object multiple inheritance issue. The problem I was seeing was I needed to have my my DB Talker friend member know of DB Talker. So DB Talker, I'll put a question mark here. This was a problem, and the only solution I was seeing was giving table model a set talker function, which really is breaking the modularity groove I was aiming for. Um, I don't want my application specific class, which in my case is table model, to have any extra code that has to deal with DB Talker friend. I just want to make calls off of DB Talker friend, you know. So how do I do this? It'd be great if I could use multiple inheritance, because then I have a separation of my responsibilities and I can follow the single responsibility principle. Um, what was the solution was using the singleton pattern. I made DB Talker a singleton. Made into singleton. And no more questions. Because DB Talker friend could call the static DB Talker get singleton function and be able to find out who DB Talker is and be able to call it. And one big note is this: there is a moving of DB Talker singleton instance to the DB thread via my QThread subclass class here, DB thread manager. And I have a whole bunch of notes, which one can look at if they want to. Just go to my DB thread manager class and just look through my code, and you can find out more about it. So this is where I'm at. This is my work in progress. There's probably lots of bugs that are still there. I do want to mention, you know what, I just thought about it. There's one thing more I want to mention. So, the cross-thread messaging is not guaranteed to be first in, first out, although the current implementation is first in, first out. So, on this main thread and the DB thread, if here we have the chronology of time here. If we have a few different operation series happening, this guy is guaranteed to happen and come back before this one. And the nature of the response chronology is first in, first out, and not first in, random out. But online research says it's probably best to not rely on this aspect. The first in, first out nature of the Qt queued connections messaging is not heavily documented and is subject to change on a whim in future Qt version releases. So, this is something that I need to be need to heed, and I have some of my own uh, issues going on. So let's say that it's a first in random out situation, not first in first out. That means that if this is a set table here and this is the second one, and um, this first send off completes last, then the unexpected behavior occurs where a select will select off of the first call and not, as desired, the second call. So I have a to do which is make the code not rely on the first in, first out nature of the Qt queue connection messaging. And it's something I just wanted to note in my code documentation. Okay, that's it. Thanks for watching.